Alright, so now we're going to review all the integration techniques in 7.5. Strategy for integration. But first, let me just remind the rules. This is a summary of all the rules that we learned on page 2 in your notes. I'm not going to write this down. Our rule, the log rule, sine, cosine, all the rules that we learned, they're on there. Okay, so that you can look at. So knowing all the integration rules, how do we go about solving an integration problem? The steps for integration. I'm going to go through this in steps. The first step is to simplify the integrand. Simplify the integrand if possible. Sometimes simplifying the integrand would do it all. Other times it won't. So, but it's worth trying. For example, if I want to do, say, integral cotangent theta over cosecant square theta theta, so I would just write cotangent is cosine over sine, and 1 over cosecant square is sine square. So it would be integral of cosine theta sine theta, which is 1/2 integral of sine 2 theta, which is -1 over 2 cosine of 2 theta plus c. So we don't really need much rules. Okay, so step 1, work it out, work the integrand out if possible. Step 2, look for u substitution. Again, you do the easiest ones first you can. So for example, number 12, page 522. If I want to integrate, say, e to the sine inverse x over square root of 1 minus x squared dx. So since I have the derivative of sine inverse right there, which is 1 over square root of 1 minus x squared, so I let u equal sine inverse x. And then du would be 1 over square root of 1 minus x squared dx. So this is integral of e to the u du, which is e to the u plus c, is e to the sine inverse x plus c. Okay. Now step 3. So if steps 1 and 2 fail, if you work out the integrand and nothing there, if you try substitution, u substitution and nothing there, then you try step 3, which is several steps. The first one of step 3 is trigonometric functions. Trigonometric functions. Integration. So if your integral is sine mx, remember those, cosine nx dx, or it's integral tangent mx secant nx dx. That's what we did in 7.2. So you go back and look at the handout from 7.2 and follow that. For example, just to refresh your memories, if you're integrating sine cube x cosine square x dx, so since sine has an odd power, so we break down one of them, so we write sine square cosine square x and then times sine x, and then we let u equal the other guy, which is cosine. So du is negative sine x dx. So we get integral of sine square, which is 1 minus cosine square, so it's 1 minus u square, and then sine square is u square, and then sine x dx, so we need a negative, so we need another negative here, so that's du. So that's integral of u squared du plus integral of u to the 4 du, which is the negative 1/3 u cubed plus 1/5 u to the 5 plus c. So we're going to bring back cosine x, so cosine cube x, cosine 5th x plus c. Okay, now if it's not trig functions, then it could be rational functions. So we're still in 3, part B. And we just did rational functions using partial fractions decomposition. So use partial fractions decomposition in section 7.4. We just went over that, okay? So like number 34, page 552. So if I'm integrating from 0 to 1, 3x squared plus 1 over x cubed plus x squared plus x plus 1. So first we notice that the degree of the top is less than the degree of the bottom. If it was equal or greater, then we do long division first. And then we can factor the bottom, that's x squared, x1. So which would be x squared plus 1, x plus 1. So if we take 3x squared plus 1 over x squared plus 1, x plus 1. The first one is quadratic, so we write linear on top. The second one is linear, so we write a constant on top. And then we times by the LCD, which is x squared plus 1 times x plus 1, so we get 3x squared plus 1. That's going to cancel out, so you get ax plus b, x plus 1. And guy is going to cancel out, so we get that. If we FOIL that guy, we get ax squared plus bx plus ax plus b. And then distribute the c. Combine like terms, a plus c x squared, a plus bx, and then b plus c. And this has to equal 3x squared plus 1. We're missing an x term, so that's a 0. So x squared equals x squared, that means a plus b equals 3. X equals x, that means c. A plus b equals 0, and b plus c equals 1. So solving this, we get a equals 2, b equals 1, and c equals -1. So the integral from 0 to 1 of 3x squared plus 1 over x cubed plus x squared plus x plus 1 equals integral from 0 to 1 of ax plus b, which is 2x plus 1 over x cubed plus x squared plus x plus 1 plus c, where c is -1, so it's -0 to 1, 1 over x plus 1 dx. Okay. I think I had them backwards. Yeah, ax plus b. So those are, let me fix these please, because I have the a and the b is different from what I have in there. So in this case, a is gonna be 1 and b is -1 and c is 2. Okay, so let me fix that, sorry. Okay, look at this, a plus c, so if a plus c equals 3 and if you times this by -1, you get -b minus c equals -1 and a plus c. So you get a minus b equals 2 and a plus b equals 0, so 2a equals 2, a is 1. And that means b is -1 because they add up to 0, and then c is 2. Okay, so yeah, because I have it in the notes different from what I have it here. So 0 to 1, 3x squared plus 1, x squared plus 1, x plus 1 equals integral of a, which is 1x plus b, so it's x minus 1 over x squared plus 1, plus c, which is 2 over x plus 1 dx. We can break down this guy, x over x squared plus 1 dx minus 1 over x squared plus 1 dx plus 2 x plus 1 dx. So this is going to be 2 ln of absolute value of x plus 1 plus that's this guy, and then 1/2 ln of x squared plus 1, that's this guy, and then minus ln minus tangent inverse of x between 0 and 1, and it's going to be 5 ln of 2 over 2 minus pi over 4. Okay. So then we review part C. If none of these work, then we look for integration by parts. So this is 3C, integration by parts, and we try integration by parts. So like number 16, page 522. So usually if f of x was x to the n times a transcendental function, like sine, cosine, tangent, log, then you use integration by parts. And sometimes it works for other stuff too. So if I want to do integral of t, sine t, cosine t, dt. Well, first I want to write it as 1/2 t sine 2t. It's easier to integrate this way. So if I let u equals t, and dv is sine 2t dt. So du would be dt, and v would be the integral of this guy, which is negative 1/2 cosine 2t. So we're going to do 1/2 u times v, u times v, minus integral of v du, which is dt. So that's 1/2 times negative 1/2, negative 1 over 4t cosine 2t, plus 1/2 times 1/2, 1 over 4. Integral of cosine is sine, and then we need to have another 1/2, so it's 1/8 sine of 2t plus c. And then 3 part D, radicals. So if you have radicals of the form for something like this, square root of x squared plus square, square root of x squared minus a squared, square root of a squared minus x squared, use trig substitution, which is section 7.3. And if it was the nth root of ax plus b occurs in the integrand, then use u substitution, u equals nth root of ax plus b. Okay? So number 68, page 522, the integral of dx over x squared square root of 4x squared minus 1. So this is going to be trig substitution. That's 2x squared minus 1. So we let 2x equals secant theta. That means 2dx equals secant theta tangent theta d theta. So this would equal the integral of 1/2, because we divide by 2, secant theta tangent theta d theta over x squared, which is secant squared over 4, and then square root of secant squared minus 1, which is tangent squared, which would be tangent, right? Square root of tangent square, that cancels this guy out, that cancels one of these guy out, so that's 4 over 2, integral of cosine, which is 2 sine theta plus c. And now if secant theta is 2x, that means cosine theta is 1 over 2x. Sine is adjacent over hypotenuse, so this would be square root of 4x squared minus 1. So sine would be opposite over hypotenuse, and that would be my final answer. Now step 4, try again. If all steps 1 through 3 fail, then try substitution again, or integration by parts, or manipulate the integral. So it takes experience to get through difficult. Relate your problem to a previous one. Or use multiple methods. Use multiple methods. Okay, so sometimes it's not easy, but eventually you will get an answer. 44, page 522. Integral 1 plus sine x over 1 plus cosine x dx. So what I'm going to do, once I have a fraction and I have two terms at the bottom and it's not clear what I need to do, I would do the conjugate. So if I take 1 sine x over 1 plus cosine x and times it by the conjugate of bottom, which is 1 minus cosine x, that's going to be, if you fill the top, it would be 1 minus cosine x plus x minus sine x cosine x. The bottom would be 1 minus cosine square, which is sine square. So now, if I take 1 plus sine x and split all that up, so the integral of 1 plus sine x over 1 plus cosine x dx. This is the integral of 1 over sine square, which is cosecant square, minus cosine over sine square, which is cotangent cosecant, which we all know what the integral is, plus sine over sine square is 1 over sine, which is cosecant, minus sine over sine square is cosine over sine, which is cotangent. And they all are known to us. So it's going to be negative cotangent x, integral of cosecant square is negative cotangent, minus integral of cotangent cosecant is negative cosecant times negative is cosecant x, integral of cosecant is ln cosecant minus cotangent, and minus ln of sine x plus c. And finally, number 82, it looks hard, but it's really the easiest one. Over 2 to the x dx. If you split it up, see, that's why we have to manipulate sometimes. Plus integral of 10 to the x over 2 to the x dx. 4 over 2 is 2. And then over 2 is 5, and we know what the integral of a to the x and b to the x is. 2 to the x over ln of 2, 5 to the x over ln 5 plus c. And that does it for 7.5. Okay, next one we're going to do is 7.8, because we don't have to do 7.6 or 7.7. 7.7 was done